The next property we're looking at is the distributive property. So in this lesson, you'll learn to use the distributive property to evaluate expressions and to simplify expressions. How can the distributive property be used to calculate quickly? Instant Replay Video Games sells new and used games. During a Saturday morning sale, the first 8 customers each bought a bargain game and a new release. To calculate the total sales for these customers, you can use the distributive property. So we could multiply 8 times the price of the bargain games and add that to 8 times the price of the new releases to get our total. Or we could add each customer's purchase price together and multiply it by 8, and we get the exact same total either way. This is an example of the distributive property. Now normally we would start with the expression on the right, distribute the 8 to both terms, and we would get the expression on the left. The distributive property says that for any numbers a, b, and c, a times b plus c equals a plus b plus a times c. Or we could switch the order and b plus c times a equals a times b plus, or b times a plus c times a. And they did the same thing with numbers here. We have 3 times 2 and 5. Or 4 times 9 and 7. So first they ask us to rewrite using the distributive property, then evaluate. So we're going to have 5 times 7 and 5 times 2. My little center dot's not very big there. 5 times 2. And then we can evaluate 5 times 7 is 35, plus 5 times 2 is 10, so altogether we get 45. And of course it doesn't matter if we're using addition or subtraction in there, and it doesn't matter that they put the 3 at the right instead of the left. So we're going to have 16 times 3, or you could write 3 times 16, it doesn't matter. So 16 times 3 is 48, 7 times 3 is 21, using PEMDAS again, and 48 minus 21 is 27. Now we're going to solve this problem using the distributive property. We could have done it a different way using the method 2 approach, but this is less than a distributive property, so we're going to do it that way. They want us to find what the total cost of the Morris family operating 2 cars would have been in 1985 if they drove the first car 18,000 miles and the second car 16,000 miles. So we need the 1985 cost of operating an automobile is 23 cents per mile. So we're going to have 23 cents. And the first car was 18,000 miles. And the second car is 16,000 miles. Okay, order of operations we would normally add first, but we're practicing making sure the distributive property works. So we're going to distribute 23 cents times 18,000. I'm grabbing a calculator. And same thing, 23 cents times 16,000 miles. Wow, this is not cheap. And add them together, and we get $7,820. The distributive property can be very helpful practicing a little mental math. I could rewrite 82 as 80 plus 2, and then it becomes something that I can do without a calculator. I know my multiples of 12, so 12 times 8 is 96, so 12 times 80 would be 960, plus 2 times 12 is 24, and then that's something that's easy to add, so it's 984, no calculator required. Okay, again, we're following directions. We're using a distributive property, so we're going to break up 3 2/3 into 3 plus 2/3. Yes, we have another algorithm to multiply a whole number by a mixed number, but we're practicing using the distributive property today. So 3 times 27, that's kind of big. Let's multiply that out. 3 times 27, yes, 81. So we have 81 plus 27 times 2/3. That's not too bad with mathematical math. 27 divided by 3 is 9 times 2 is 18. And then all we have left to do is add 81 plus 18 is 99. Now these are the type of problems we like to do with the distributive property because we have a variable. We have no choice. We can't add y plus 3 because we don't know what y represents. So we're going to multiply 12 times both numbers. We're distributing like Santa does to the good children at Christmas, distributing the gifts. So we have 12 times y, and we write it right next to the y, plus 12 times 3. And of course, we can simplify 12 times 3 as 36. Now, I have that variable there, so I can't simplify it anymore. I have two different terms. A term is a number, a variable or a product or quotient of numbers and variables. For example, y, p cubed, 4a, 5g squared h are all terms. Like terms are terms that contain the same variables with corresponding variables having the same power. So this expression has three separate terms, and like terms have the same variable raised to the same power, so 3a squared and 5a squared are like terms. The 2a isn't squared, so it would represent a different value for a most of the time, unless a was 0 or 1. And so the a squared and the a are not like terms. They're unlike terms. Again, we're rewriting using the distributive property. So we're going to want to take 4 times all three terms. How to get that vocabulary in there as we're doing the problem. So we're going to have 4 times y squared plus 4 times, we use a parenthesis this time, 8y plus 4 times 2. So the y squared doesn't need to be simplified, it's fine. 4 times 8 is 32, I just have my y, and 4 times 2 is 8. So that is completely simplified because the rest are not like terms, we cannot combine them. The expressions 5n plus 7n and 12n are called equivalent expressions because they denote the same number. An expression is in simplest form when it is replaced by an equivalent expression having no like terms or parentheses. And we can kind of use the distributive property in reverse, kind of undistribute here to show why that works. So if we take out the n out of both terms, we would have 5 plus 7 times n, and we know, of course, 5 plus 7 is 12. So 5n plus 7n is equivalent to 12n. So the same way here, we're going to kind of undistribute, and we're going to take the numbers out. So we have 17 plus 21 would have been multiplied by a, and 17 plus 21 is 38. Okay, so we just added like terms. Now the like terms this time are going to be the b squared, so I'm going to have 12 minus 8 b squared, and the plain old b doesn't have a friend, so he's just staying where he is. So 12 minus 8 is 4 b squared plus 6b, and sorry, my 6 and my b look too much alike. And that will be our final answer. We cannot combine the rest. We cannot combine any more coefficients because they are not like terms. The coefficient of a term is the numerical factor, so the number in front of the variables. For example, in 17xy, the coefficient is 17, and in 3y squared over 4, the coefficient is 3/4. In the term m, the coefficient is 1, since 1 times m equals m by the multiplicative identity property. Summing it up for any numbers a, b, and c, a times b plus c equals a times b plus a times c, or vice versa. B plus c times a is the same as b times a times c plus c times a. And the same is true of subtraction. A times b minus c is the same as ab minus ac. And b minus c times a is the same as ba minus ca.